Hello everyone, my name is Kyll Schomberg. I'm a PhD candidate up at the University of New South Wales in Sydney, Australia, and we're going to do a walk through the supersonic nozzle rig, and then we're going to run some experiments. So as you can see, we've made the treacherous journey through the dungeon, and here we are at the fluidic thrust vectoring lab, or formerly known as. So we'll just change this over because experiments are in progress. So here we are at the nozzle lab, about as pleasant as our surroundings. Got it all happening here. So our flow is going to be provided by these 4 gas bottles, courtesy of them. In terms of data acquisition, we've got the state-of-the-art HP, no Pentium 3 for us. This is a full Pentium 4 packing 1.6 gigahertz and half a giga RAM. That's going to be measuring our mass flow variables from the mass flow meter, as well as the force from the force transducers. Our Shreelan is going to be captured on this by the Red Lake high-speed camera. We're at about 5,000 frames per second there. Slight flickering, that was due. The Red Lake actually had a fight with the ground once, came second, but we'll push through. So as you can see, here is the Shreelan setup. So here you can see here we've got our light source, cleverly disguised as a tin lid here, but it's a very scientific pinhole. And we've got our 2 lenses, focal length of about 500 mils there. Here's the nozzle rig itself. You can see we're using the X-Tran load cells, 2 radial, 2 axial there. You get in nice and close here, you can see there's the nozzle geometry. It's about a 1 to 100 scale. And we're using planar, and we're using Perspex windows to have a look at the flow field there. Come back, we'll just see that we're using vertical cutoff. We're cutting off about 50% of the light there, and that's to resolve the density gradient in the dx direction. So let's run through how the actual setup goes. So here we've got our gas tanks. We open these, open all 4, that's to keep the stagnation temperature up so we don't condense or vaporize the air around us. Here we've got the pressure gauges. We've got a high pressure and a low pressure here, and this is our regulator, so we're going to wind this out to give us the pressure we want. Here, this is our makeshift manifold. These valves can isolate or open, these ones here, isolate or open each of these tanks, down to our master switch down here, so that starts the flow to the rig. This is the primary flow meter. That's going to give us our mass flow, our pressure and our temperature at this point, and going through this hose and finally leaving the rig all together. So let's fire it up and see what happens. I'm just going to take a video of the actual test. Alright, yeah, so start the data. And 3, 2, 1, go.